Good morning. Uh, it's funny how time seems to fly so quickly. Here in our Math 121 intermediate algebra class, we are now ready for our first opportunity to show what we've learned. So I'm going to go over the practice test with this first video here, starting with looking at linear regression, how we can use it to find, when we're asked to find the line equation of the regression line, as well as using it for average rate of change, and when we're just given 2 points and asked to find the equation of the line. So we're going to do all this. I'll show you how to use the table in the graphing calculator, as well as the graph, stat plot, everything, step by step with a key press history, so you can go back and look exactly what keys you're pressing, practice it a bit, and so this will become second nature for you, because remember, we're going to use this many times throughout the rest of this course. This is not something you learn once and then take a test and you're done. You do learn it, you take a test, and then you learn it again and take a test. This is going to be something we're going to use in our exponential study, our quadratic study, and you'll use it quite a bit in college algebra as well and beyond. So once you get this technique down, you'll find the rest of it pretty straightforward. So let's go ahead and get started with linear regression. So here we have a problem from our practice test, as you can see, and we're asked to consider this data below. And we are given hours since 4 a.m., so 0, so that would be 4 a.m., 6 a.m., so forth, but hours since is 0, 2, 4, 6, 8, so forth. That's going to be our x variable. Then we've got the temperature, and we see that the temperature is rising, and we're asked to use our calculator to determine the equation of the regression line. Okay, and then we'll write the results below. Again, remembering to round the coefficients to the nearest tenth, so we'll talk about that. We're going to go into the calculator. We're going to use this button here, the stat button, to get things started. So you'll see that that will get highlighted, and that's what we're going to use. And then what we're going to do is we're going to input our data. List 1 will be the x values, and list 2 is where we will put the y values. We will then take a look at the scatter plot, make sure it looks linear. We will then calculate the linear regression, and then we will see the graph again with the linear regression entered in. And then we'll write it here and answer a few more questions that are below this. Okay, so the first step is we hit the stat button. Now that we've done that, let me go ahead and clear. Okay, so our stat button, and down here you'll be able to see our key press history. So I just hit the stat button, we get this menu. That's what you should see on yours. We're going to hit the enter button, which takes us to the window where we can put things in. And in list 1 is where we're going to put the x values. List 2 is where we're going to put the y values. I find it easier to enter all the x values first. So 0, enter, 2, enter, 3, enter. Oops, we don't have a 3. Sometimes you have to pay attention a little more closely, but it's easy to change. There's 4, enter. 6, enter. Yes, the hardest part of this is making sure you have the right data in there, because you put the wrong values, you're guaranteed to get the wrong answer. You put the right answers, or right input, you're guaranteed to get the right answers. Okay, so we've got all our x's in. We arrow over, and now we'll put in our list 2, which is our y values. 23.8, enter. And I might switch over to the keyboard. 24.8, enter. 25.9, 25.9, enter. 26.2, enter. 26, 27.9, enter. 27.1, enter. 27.9, enter. And notice I have exactly the same number of x's as y's. That's very important. If we're missing something, it's not going to work. So this is what we should see so far. The quick way just to get the regression line, since that's all they're asking, is you hit the Stat button, and then we're now going to go over to Calc by hitting the arrow button. And what we will be doing is linear regression. So let's put this in here first, since that's what they're asking, linear regression. I'm going to hit Enter. You can either arrow down. I just like to hit Enter a bunch of times and accept all the defaults. If you have a TI-83, what happens is you just get a line that says linear regression. You just hit Enter once and you get the calculations going. Okay, so different versions of the calculator may look different. Okay, so now what we're going to do is actually write this as an equation. So notice this is the model of the equation. It's y equals ax plus b. Down here they give us a and b. So when we write our answer, it's going to be y equals, we take the value of a, and since they want, our instructions tell us to round it to the nearest tenth, we're going to write this as 0.3, rounding it to the nearest tenth. 1 is not halfway, so we round it down to 0.3. And then what comes next is the x value, the x, plus the value of b, 24 point, in this case we're going to round up to 2. Okay, so that's the answer we're going to write. Let me clear the calculator part off, or clear the writing off the calculator. And then we'll write that down here. This will be the answer that we're going to want. Okay. But while we're at it, I want you to show you the full functionality. We can also look at a scatter plot. And if you'll see above here, the y equals, there is something that says scatter plot. So we're going to go second, scatter plot. We're to a new window. Fortunately, mine's already turned on. So scatter plot 1 is on. If it's not on, what you do is you just hit Enter. And if the off is highlighted in the black, you'll be on the on. You hit Enter. You accept all the defaults. This is a scatter plot. X's are in L1, Y's are in L2. The mark would be a big square, and in my case I have color of blue. There are other types of graphs you can do with this, which is really great, but we won't be using them in this class. The next thing we want to do is when we graph this, we want the data to fit the window, or the window to fit the data, however you want to think of it. But the zoom function is what's going to do that for us. And there's something here, number 9, called zoom stat. If you don't see it on your calculator, just arrow down till you get to number 9 and you'll see zoom stat. Or if you want, you can just hit 9, but you've got to remember why you're hitting number 9. And then it zooms the window to fit the data. See, perfectly fit. Here's all the data that we entered. It looks pretty linear. It's not a straight, perfectly straight line. But what we've done is we found a line that will fit it very well. So I'm going to go to y equals. I'm going to enter the line that we found. So we've got our y equals, and I'm going to put 0.3. The x is from up here. Here's our variable key. There's our x plus 24.2. I'm going to show you a little trick because our dots are in blue. It'd be nice if our line was something else. And if you arrow over, you can change the settings for your graph. If you don't have a color graphing calculator, you can change the thickness of the line and such. So I'm just going to hit Enter, and then instead of blue, let's make it red. Okay. You could change the thickness of the line as well, and those kind of things. So that's a nice little feature. Arrow down until it says OK, hit enter, and there we're good. We're going to hit the graph button, which is right here, and there we see our line fitting the dots, the data points, very nicely. So that's linear regression. We've got the line, it fits the data. And now what we can do is if we want to know some x value, what's the y value, we can interpolate with the line itself. And the reason I went through this, while it doesn't seem like the question is asking that, if we go down a little bit more over here in our practice test, we will see that actually they are asking about that. So let me clear this. We're going to go keep on going. Use the result from part A to estimate the value of y when x equals 9. Now we could have used that equation, plug in 9, and got the value of y manually. But let me show you two other ways we can do that now that we've got the equation entered in the graphing calculator. Okay, so one way is, since the graph is up here, we can hit the trace key. Right now we have a little, I call it a little spider. It's only got 4 legs, but looks like a friendly spider to me. We currently are on the plots, and so if we go left and right with our arrow, we go to the different data plots. It's kind of cool, and down here it tells us what x and y is. We want to get our value, though, from the line. And notice there is no 9 here. There's an 8 and a 10. We're somewhere in between. So what we want to do is either arrow up or down. It will take us to the next object on the graph, which is the line itself. And again, now when we hit the right and left arrow, we walk along the line. Okay, so we can see various x values, their y value. If we want to jump to x equals 9, the cool part is all we have to do is enter the 9. So see the 9 button, I'm just going to click it. Oops, not 99. Let's clear that. Just 9. X equals 9. When I hit enter, my little spider friend jumps to x equals 9, and it gives me the answer right there. So that I'm able to come to my test and say that y equals 26.9. That's all there is to it. I looked it up. We'll answer the practical meaning in just a moment. But one more thing, there's another way I could have looked at this. I could also look at the table of values. So what I want you to see is on the graph button, above it is a blue thing that says table. Anything in blue, we have to hit the shift key first, the second key. Hit the second key first. That sounds strange, but it's true. Now we've got a table of values. If your table of values does not look like this, it's because somebody has played with your table set. Second table set, which is right above window. Mine has a table start at 0. The table is changing by 1, and both the independent and dependent are on auto. If yours is anything else, arrow down and change them. Okay, so if you were on ask, which is one issue, which is actually not a bad place to be, but we'll talk about that one later. You want to be on auto so that when you go back to table, you now can see this. And again, we see 9, when x is 9, y is 26.9. Okay, how are you feeling about using the calculator so far? Good. So finally, what is the practical meaning of the slope in your regression equation? Actually, for that one, we're going to have to go back up to the original problem. Practical meaning, remember, slope is y's over x's, so temperature per hour. Practical meaning of slope is going to come right from here, from these so it's going to be in temperature per hour. And remember from the equation, back to the y equals, the equation, the slope was 0.3, or 0.3. So that means 0.3 degrees Fahrenheit per hour. Okay, so we can go ahead, come down here. That was for there. What's the practical meaning? Temperature changing .3 degrees Fahrenheit per hour. If we want to be more accurate, we could say not just changing, let's come back here, increasing, because it's a positive slope. Okay, wonderful. You can see this in the Canvas course. I do have the solutions just written out, but here's a video that will walk you through actually doing the linear regression. Now at this point, it's up to you. You could stop watching the video because you've got it down, but if you want to press ahead, what I'm going to do is I'm going to go to the next one that's a little bit, well, this one is a little different. Let's see, where can we, here we go, we can use our regression capabilities to find the slope of the line through these 2 points. Okay, so additional practice. We're now given a new problem. We've got 2 points and we want their slope. We can do this manually, but I want you to also get practice on your newfound calculator skills. So what we're going to do is we're just going to go to Stat, Enter, and we're going to put in our data. Our data will be the x values and the y values. So we're going to clear out this list, which is something I don't remember if I showed you. You go to the top, clear, and enter. Arrow over, go to L1, clear, and enter. I did show you in class, but I don't think I started with it. Let's clear off this here. Okay, so now that we're clear and ready to start, we put the 7 and the 11 in as our x's. 7, 11. Arrow over, we put the y's in. 13 goes with the 7 and -3. And remember, you have to use this is the negative. This key up here is a subtraction key. They are different. And you will get a syntax error if you use the subtraction key instead of the negative key. Okay, there we go. Enter. We've got our 2 points in. We go to Stat. We go over to Calc. And then we go down to number 4. We're going to do this a lot of times. You're just going to see every time you want it. 2 points, you get an equation. And again, just get used to doing this over and over again. One more enter. And there's our equation. So now we are able to write it in. Oh, well, they don't actually want the equation of the line. Okay, so they just want the slope. The slope is the a value. So the slope is equal to -4. We're done. That's it. Good enough. So let's keep going. Let's see what else we can do with our newfound, what do they call this, superpower or something, find equations of lines with the calculator. Let's see, here's other part of that. Here we go. This is where it's going to actually be very powerful. And this one is one where students will mix up a little bit, because when they do this, they want to put all the x's in, 1, 2, 3, and then the y's in. But notice there is no y value for 2. So we're going to use a linear regression, but we're going to, since we don't know the y value for 2, we're going to hold off for just a moment. Okay, so here's another problem. Going to need linear regression. So we're going to go to Stat. And what we're going to be writing down is just the 2 points, 1, 16, and 3, 36. So we're going to enter in these. These are really the only 2 points we know right now. So we put the 1 and 3 in L1, the 16 and 36 into L2. So we're ready to go to the edit page. We need to clear out our data, so we arrow up, clear, enter, arrow over, arrow up, clear, enter, just like that. We enter the x values, 1, enter, 3, enter. Cool part about a video is you can always slow me down or speed me up, whichever you need. Y values, 16, enter, 36, enter. Notice we did not use the 2, the x value of 2, because we do not know what the y value is. Now that we've got this, what we do is we go get the equation that fits the 2 points, because we're told the data is linear. See, how do we do that? We hit the Stat button, we go over to Calc, and down to number 4. And again, you could just enter number 4. Hit Enter. Remember this screen. Enter a bunch of times or arrow down till you get to Calculate, or in the TI-83 just hit Enter and it will calculate your linear regression line. Okay, so that's saying that 10 is the slope, the y-intercept is 6. So it's saying we've got an equation that we can use, y equals 10x plus 6. Now what we can do now is take the 2, plug it in for x. Let's do it old school, and I'll show you both ways. And the calculation's not too difficult. 10 times 2 is 20, plus 6 is 26. Wow, there it is right there. The other way, which is good practice, is we can put this equation into the y equals part. Let's clear out the old one. And I'll show you another way to turn plots off, because sometimes plots can cause problems. I arrowed up and I'm going to hit Enter. I just turned my plot off because it's just good practice to do that. And then again, I'm going to enter 10x plus 6. We always need a variable in here, or else we'll end up with a horizontal line if we put all numbers. Okay, 10x plus 6, there's our equation. I can now go to the table, which is probably the best place to go. When x is equal to 2, y is equal to 26. There's my answer right there. Okay, sounding good? Let's keep moving forward and see if there's any more in this test. Here we go. They want the actual equation of a line passing through these 2 points. With our newfound skills of doing linear regression, this also is, I guess, like playing a video game more than like doing math, but we're using a math tool to do it. So we've got the 2 points, negative 2, 4, 6, and 20. We're going to come back to the calculator, and we're just going to jump to the Stat tool. It doesn't matter what window we're on. We don't have to clear anything out. We just hit Stat. We go to Enter. And now's the time to clear out the old data. Arrow up, clear, Enter. Arrow over, up, clear, Enter. Oops, I bet I should have been watching what I was doing, right? Go to the very top, clear, Enter, clear, and Enter. Okay, now we enter our data, which is sort of covered up, so we'll click down here. See if I can move this down a little bit. There we go. So that when I come back to this, I can enter in my x values of negative 2, enter 6. And I can come over here, I can enter my y values, 4, and 20. Got them entered. We hit the Stat button. We go over to Calc. We go to number 4. We do our thing. Hit enter a bunch of times or once if you're in the TI-83. There's our equation. A equals AX plus B. A is 2, B is 8. So that would be 2x plus 8, sitting right there. Notice, no work to show because we did it all on the calculator. These skills that you're building are going to help you in the next section because we will, when we get to exponentials, we will be doing a similar thing. We'll be doing exponential regression. The steps will all be the same, but instead of using option 4, linear regression, we go down to exponential regression, and we get that equation as well. This is a very powerful tool, and we just need you to practice, practice, practice so that it's second nature, so that you don't have to think too much about the steps. You don't need to have any kind of notes because you remember how to do the steps and they're kind of second nature for you. Let's see, that one we'll do later. This one, okay, let's go ahead and do this one. But this one is a little different. It wants the average rate of change. Okay, so I'm going to show you how this is different. We're not going to enter all the data. So it's a table. Let's see. The table below displays the average amount of bottled water consumed per year per person in liters for people in the U.S. between 1999 and 2004. Very good. Questions here, though, is determine the average rate of change. And remember, you could stop watching this video at any time you get bored and don't want to see it. But if you are interested, this will really help out. The average rate of change. That means we're taking two of these points and then we are going to find basically the slope. The 2 points we're going to use is 2000 and 2002. So we ignore everything except the 2 points here and here. We'll use our regression calculator to get that slope, get that rate of change, realizing that the t value up here, the years, that's going to be in our L1, and the liters of bottled water consumed, that's going to go into L2. Okay, so we'll come back here. Again, no need to clear anything out. Just hit the Stat button, hit enter, and now's the time to clear it out. Arrow up, clear, enter, arrow over, arrow up, clear, enter. Okay, put our data in. First data point is 2000. Enter. Second data point, 2002. 2002. And again, just be sure you've got the right numbers entered in. The first y value is 67. Enter. And the next one is 82. We're going to go to Stat, over to Calc, down to number 4, which gives us the linear regression that contains the slope, which in this case, the slope of the line connecting the 2 points, and in this case, that is the average rate of change. So we see here it's the A value. The A is 7.5. And so in this one, a multiple choice test, we just have to circle that. Now the thing is when people do this by hand, they'll take 82 minus 67, they'll get 15 and they'll think they're done. They forgot to divide by the 2-year difference to get the average. So by doing it with the stat feature in the graphing calculator, you get the real understanding what's going on here. We're getting the average rate of change between these 2 points. Okay, and that's what we're looking for. Excellent. So some multiple choice, some not multiple choice. Either way, we need to go through this. Let's see what else is there. I think we're almost done. We'll come back to review some of these and the next steps. These are functions or not functions. Here's one more regression problem. So we'll end it here. So after some extensive market research, I found that in a certain area there was an interesting relationship between the number of homes sold this year and their price. The following table gives the number of new home sales as a function of their price. So notice price is the input, the number of homes sold is the output. And it's pretty clear here. Use your calculator to determine the equation of the regression line, the line of best fit. And again, we just have to choose the right one. So what we're going to do here, see if I've got my pen, is the x values we're going to enter in as L1. The y values we're going to enter in as L2. We're going to go over to the regression calculator, have it calculated, and it'll give us one of these equations as our answer. Here we go, a little bit higher. Okay, so let's return to the calculator. Again, just hit the stat button. We'll go directly to it. We're going to go to the edit. We're going to go up, clear, and enter. Go to the L1, clear, and enter. Now in this case, this is not average rate of change. We want actually the regression line. So we have to enter in all this data. So we'll start with 160 and we'll keep going. So we'll enter in an L1, 160, enter, 180, enter, 200, enter, 220, enter, 240, enter, 260, enter, 280, enter. And then we arrow over and we start putting in the y values. So 137, it's kind of like a player piano, it looks like. 115, 95, 79, 82, 55, and 35. Now be careful again, if you enter in one of these wrong, you could get a very different equation than if you did it correctly. Notice that there are the same number of x values as y values. That's important. Each x value is paired with its corresponding y value. That's important. Now when we hit stat, go over to calc, and then do number 4. I don't usually like to remember numbers because, you know, things change. So linear regression, that's what they're asking us to do. That's what it says. Enter, enter several times. And now watch what they do to us. It's negative 0.78 is the slope. 257, which could get rounded to 258. So look at down here. There's two that sort of look right, but again, which one is correct? It's the one with the negative 0.78 is the A value, right? A goes in front of the X. So this number goes in front of the X. Okay, this is our y-intercept, which they've rounded to 258. So the correct answer here is A, not C. The other ones come from I don't know where, maybe entering things in wrong. Anyway, that's what we have. That's the power of linear regression. So I will go back and work some of the ones we didn't, the ones by hand, the ones domain and range, some of those other ones. But this is the practice test you have to work on. You'll be facing similar type questions on the actual test. You'll be well prepared as you go through this, though. You will see similar type problems, and you'll be just fine if you practice how to use the linear regression and the other concepts that we have in this section. All right, we'll see you soon.